Okay, we're going to go over horizontal asymptotes behaviors. Okay, so this question here specifically states the limit as x tends towards negative infinity. So first thing first is we need to find a value. Okay, and if we're tending towards negative infinity, we're looking for a value that would be considered a horizontal asymptote. Now, if you recall, first step we want to do is divide the top function of the rational and the bottom by the factor of the greatest term here. Okay? So what we mean by that is we're going to be taking out x from our top, and we'll be left with 1. X is our common factor. We're going to take out the factor with the highest term again from the bottom. Well, the factor with the highest term again was x squared. So when I divide that or take it as a common factor, I'm left with 1 plus 1 over x squared. Okay? And this is still our limit. We're still trying to find the limit of all this. Okay. Well, this x will cancel out. We'll be left with just an x on the bottom. I have 1 over x times 1 plus 1 over x squared. Okay. Here's where we're going to start to plug in our limit now. So normally they use their proper notation for it, where they apply the limit to any value of x in this question. So the question would now read 1 over the limit of x as it tends to negative infinity for x, and we're going to find the limit of 1 over, sorry, I should write the limit part first. The limit of x as it tends to negative infinity for 1 over x. Now, for our work, I don't need you to write the proper limit notation. You can skip this step. I'm just putting it in because I know they do this in the textbook in case you're wondering what they're saying. Well, what they're doing here is they're plugging in an infinite value for infinity. Okay? So in other words, what I want you to think of it like this. Oops. Our x value is now an infinite number. And we have 1 plus 1 over an infinite number. Well, we know 1 over an infinite number is going to be 0. So we have 1 over infinite number 1 plus 0. Well, that's just going to be 1. And what's 1 times an infinite number? Still going to be that infinite number. So we have 1 over an infinite number. What does that tend to be if we have 1 divided by an infinite number? 0. So what they're telling us is our horizontal asymptote is at 0. But we haven't actually answered the question of as x tends to negative infinity. And we're going to explain that in a minute. We know we have a horizontal asymptote of 0. Come on. There we go. Let's bring this down a bit. Okay, so we have a horizontal asymptote, an imaginary line going through 0. Do it in red. So this is our horizontal asymptote. Now they asked as we tend, or as x tends towards negative infinity. What they mean by this is as x is heading in the direction of negative infinity. Well, in that case, that would be when our x value is headed this way. We're trying to figure out if it's coming from the top or coming from the bottom when it tends towards this. And what we're going to do to figure this out is we're going to take our original equation, which is our f at x. We'll rewrite that again. Our f at x was x divided by x squared plus 1. And as we head towards negative infinity, we're going to put an extremely, well, you wouldn't say small, but an extremely negative value. Okay? So a large negative value in for our x's. In other words, a large value in the negative direction would be something like 10,000, 3,000, but a negative form of it. So in other words, let's say x at negative 5,000. Okay? I'm going to plug that value in. So when I find f at negative 5,000, I'm left with negative 5,000 divided by negative 5,000 squared plus 1. Well, when we square that negative 5,000, we're going to get a positive value. So we have negative 5,000 by a very large value, but it's going to be positive on the bottom. This is what's important again. Are we getting positive Or sorry, not positive, negative. Are we getting values larger than the original when we plug it into the equation? So this large value here, let's actually figure out what the value of it is. 5,000 squared is 25 million. Perfect. Plus 1, so 25 million and 1. 1, 2, 3, 4, 5, 6. There we go. And when we divide this value, we're going to get a negative 5,000. What's my negative sign? Negative 5,000 divided by 25 million. Negative a very small number. Okay, this number is important. Negative very small number, so negative 0.0001-ish, something like that. This number is important because we also have to find out with our limit if it is larger than our original value. Okay, and what we mean by that is when we plug 0 in for our x value, because 0 was our horizontal asymptote, if you guys remember. When we plug 0 in for this, oh sorry, that's not right. Are we larger or greater than 0? Or smaller or larger than 0? 0 being our value of our horizontal asymptote, so we know y is equal to 0 in this case. Is this larger or smaller than 0? What's that? Less. It's smaller than 0. We're less than. So in other words, as we approach 0, we're coming from below it because we're less than that value. So wherever it's coming up from, it's coming from below and tending towards negative infinity. Okay? That's how we know what's happening. We're coming from above or below it. We're tending towards negative infinity and we're coming from below. We'll go over another example like that.